Hi, hello everybody. So this is the video dealing with section 2.3, polynomial functions and their graphs. And this is the third part of this section, graphing polynomial functions. So this is actually where we're going to go and sketch the graph using all that we have learned in parts 1 and part 2. So we're going to do this using these 4 steps that I have over here. We can do it in this order. You can change the order a little bit if you want to, but I think this is the easiest way for you, where we first find the y-intercept by finding f of 0. Then we're going to use the leading coefficient to determine the end behavior of the polynomial as x goes to either positive or negative infinity. After that, we're going to find the roots or the zeros of the polynomial by solving this equation. And we're going to do that by factoring the polynomial if it's already not fully factored. And when we do, after it's fully factored, we're going to find the multiplicity of each root. Remember that if the multiplicity is even, if the exponent on the factor is even, the multiplicity is even, which means that the function bounces back in the same direction. And if the multiplicity is odd, the exponent on the root is odd, the function will cross the root at that particular value. And then this may be important or necessary in some cases. We need to know the behavior of the polynomial between each root. Okay, so this is important. So we need to know exactly where the polynomial is, if it is above the x-axis or below, between each root. And once we have all of these 4 pieces of information, we do 5, which is we're going to trace a smooth, continuous curve or line through all of these points, or in the direction of the end behavior to sketch the graph of the polynomial. So these are the 5 things that we have to do. Normally, I suggest you do them in this order, but you may do it in a slightly different order and it will be okay. Okay, so I have 2 examples, and these examples are pretty much all that you are going to be able to see in our course. They're not going to get any more complicated than this. Let me just move this a little bit over here. It would be nice if we could make it a little bit bigger, but this is okay. All right, so let me just explain a little bit the 2 types of functions that you're going to see in our course. And have seen them before. In example 10, I give you the polynomial. This is in the textbook, by the way. I give you the polynomial in fully factored form. So this is a little bit easier because it's very easy to pick out the roots and their multiplicities. And usually you can do this a little bit faster. Now, in this example A, I don't give you the polynomial fully factored. So in this case, you will have to factor, as we saw it in a previous video, which is okay. It's not that bad, but just a couple of extra minutes of work. Okay, so let's begin with example 10, and we begin by finding the y-intercept or f of 0. Right? So all I have to do is I have to replace x with 0 and find the value of the function. So 0 minus 1 square, 0 plus 2, right? So negative 1 square is positive 1. So negative 2 times positive 1. And obviously 0 plus 2 is just 2. So this is negative 4. So I have the y-intercept. Now, I could find, as I said before, the end behavior, but this is already factored form, so it may be easier just to find the roots and the multiplicity. So I'm going to write here roots and their multiplicity. So for the roots, all I have to do is set each factor to 0. Obviously, if it's not factored, I would have to factor first. But once it's in this format, I set each root to 0. So I'm sorry, I set each factor to 0 and I solve for x. Obviously here, plus 1 on both sides. This is one root, and minus 2 on both sides. This is another root. These two obviously cancel. Okay, now so these are the roots. X equals 1, X equals -2. And now for the multiplicities, I have to look at the polynomial in factored form. Okay, and I have to look at the exponent above the factor. This one has an invisible one right here. So the one root, because of the exponent 2, I have an even multiplicity, meaning that the polynomial is going to bounce back in the same direction at 1. For the root -2, I have an odd multiplicity, meaning that the function is going to cross the root at -2, either from bottom up or up down. Okay, so this is how the roots matter. All right, so I have the roots, and now I want to find the end behavior. So the end behavior of the function, as we've seen before, is as x goes to positive infinity, we find out the behavior of f of x. Okay, now, and for that, I need to, you can't really replace infinity here. So you pick a very large value or a very small value in here. Now, you normally have to pick, normally positive or -1, positive or -2 is enough. But in this case, these are the roots. So I cannot pick up these values. So you pick a value that is bigger than the biggest root and smaller than the smallest root. Okay, so I'm going to pick a value bigger than 1. So about 3. And for the other side, as x goes to negative infinity, I'm going to pick a value smaller than -2. So how about -10? Now, keep in mind, I am not interested in the numerical value of each, just the sign of the function at that location. So -2. So for the f of 3, I'm going to replace x with 3. Okay, so -3, 2, 3 minus 1, just 2 square, and then 3 plus 2 is just 5. I don't really care about the numerical sign, the numerical value, just the sign. So this is positive, 2 square is positive, so positive times a positive is positive, times a negative, negative. So the function is going to negative infinity. Okay, for the -10, same thing, right? So I'm going to evaluate this thing, only worrying about the sign. So -2, -10 minus 1 is -11 square, and -11 plus 2. So this is negative. -11 squared is positive, and -2 is negative. So I have to multiply these three signs. So negative times a negative is a positive, times a positive is a positive. So f of x goes to positive infinity. So this is the end behavior. All right. So I have these three pieces of information now, and I'm going to plot them in my graph. Now, because the graph is kind of small, I'm going to make two of these little tick marks. So each tick mark, I'm going to say it's half, just to make it easy for us to see. Okay, so I'm going to plot -4. I hope I have enough. 1, 2, 3, 4, 5, 6, 7, 8. So let me say that this is -4, right? Because, each one is half. All right. Now I have to plot x equals 1. This is one of the roots. So here is, let's say that this is 1, right? Because each tick mark is half. And I have to plot -2. 1, 2, 3, 4. And let's say that, so this is x equals 1. And let's say that this is x equals -2. All right. All right. So I have the 3 points in. Let's take a look at the end behavior. So as x goes to, so the end behavior is the behavior of the function after or outside of the last root. So this is end behavior after here, and here's my last root. So this is the end behavior that way. So as x goes to positive infinity, the function goes down. So after the last root, the function has to go this way. Okay. For the negative infinity, so as x goes to negative infinity, the function is going positive. So after the last root in here, the function has to go up. Right? So this is the end behavior of our function. All right, so what do we do now? I am going to connect these points. Maybe I want to find where the function is in between here. Maybe it's not necessary, but in this case, I feel like I want to. So I am going to pick a value in the middle. So remember, each of these tick marks is a half. So I'm going to find out where the function is at -1. So this is my extra point. I'm going to find out what f of -1 is. So I go into the obviously original equation or function, -2, -1 minus 1 square, -1 plus 2. So this is -2. This is -2 square, which is 4. And this is +1. So this is -8. All right, so let's see where -8 is. I think it's down here, right? 2. Actually, because of the tick marks, it's going to be pretty low. I'm not going to be able to see. It's going to be down here somewhere. So how about if I do anything? So remember, each of these tick marks is 1/2. So this is 1, 2, 3, 4. So it's going to be way, way down here. Okay. Which is fine. Let's say it's down here, right? -8. And now I am able to graph this polynomial. Let's see how that will work. I'm going to remove this. I'm going to remove this. Now, what I said before was when you have all of the, so we have the two roots, we have the y-intercept, we have a point in between the root. All we have to do now is, as you see here, item 5, we have to trace a line through all of these points and in the direction of the end behavior. So here's the end behavior. So I am coming from here. Now just bear in mind that this is extremely hard to do. Yes, it looks atrocious, but on a piece of paper, right, you should draw something that looks like this. Okay. So normally what we do is this. We erase all this stuff. When we have an idea what the polynomial looks like, we'll do this. And then we label this as -2. This, remember, was your -8. This is your -4. And this is your x equals 1. So this is what this polynomial here looks like. It's a sketch. It's not a perfect graph because we need calculus to find exactly the locations that we're interested in, but this is a very good sketch, not knowing calculus. Okay, and it's using these 5 points that we have specified here. Okay, very good. So now let's do the second example. I'm going to erase all of this stuff. So this example is in the textbook. So if you want to follow the specific details more in detail that I have, especially, not having to write at the same time, you can take a look at the textbook, which is in Brightspace. All right. So second example, as I said, it's different from example 10 because the polynomial is not fully factored. So the very first thing that I have to do is I have to fully factor this thing. Okay. So f of x. And I'm going to use one of the basic techniques that are required for factoring, which is greatest common factor, grouping, trinomial, or difference of squares. And I can see I can factor certainly a -2, and I can factor an x squared out of this polynomial. So I get x squared, and I get -2, right? So we can check. Foil back. So I have -4x squared and positive, I'm sorry, -4x to the fourth, and then positive 4x squared. This is perfect. So this is the polynomial fully factored. Now I can find the y-intercept, which is f of 0. So replace x with 0. So this is 0 squared, 0 times -2, 0 times 0. So this is 0. So y-intercept is 0. Now, because this is already, again, fully factored, I could do the roots first if I wanted to, and their multiplicities. So set each factor to 0. Solve them for x. Okay. So obviously, in this case, to divide everything by -2 and take the square root of both sides, and we get this. In this case, this is difference of squares. So you can do one or two things. You can apply difference of squares, or you can apply the zero property root, which is add 2 to both sides. And now take the square root of both sides, okay? Which is this. Positive or negative square root of 2. It's okay that this is not a integer. It's perfectly fine, okay? Doesn't matter. Okay, so this polynomial, as you can see, has 1, 2, 3 roots. Now, at 0, no, not here. Here, right? Here is the exponent where the 0 root came from. So this is an even multiplicity. And here is the factor where the plus or minus square root of 2 came from. So this is, again, an odd multiplicity. All right. So at 0, the graph is going to bounce. At plus or minus square root of 2, the graph is going to cross. All right. So we can, I'm going to maybe make this a little bit, and make it a little bit bigger. All right. The end behavior. So we need the end behavior before we start graphing. So the end behavior. And again, the end behavior, once the polynomial is in this form, we use this form because you remember the end behavior is just on the leading term. So minus 2x to the 4. In this case, you can definitely do +1 and -1, right? Okay, once it's in individual terms, you can just plug in the +1, -1. So this is -2, 1 to the fourth. This is -2, which means that the function, and remember, we're only concerned about the sign, goes to negative infinity. -1. So -1 to the fourth is also 1. 1 times -2, -2 again. So the polynomial goes to also negative infinity. So in both cases, as x goes to negative infinity, we get the polynomial going to negative infinity. All right. So as x goes to positive infinity, as x goes to negative infinity. So in both cases, they go down. Okay, so with this information, we are able to graph. So let's do this. I am going to plot the zero. Actually, let's plot the y-intercept first. And we're going to try to do the same thing. Let's make each of these tick marks equals to a half. Okay, and now the square root of 2, this is approximately 1.4. So double, that would be 2.8. Okay, plus or minus. So let's see, 2. So yeah, let's say, to make it easy for us, this is my radical 2, and this is my radical -2. Okay. Otherwise, it gets too complicated to graph these things. It's already complicated on graphing paper on a computer. All right, so I plot the roots. Now let's do the end behavior. So in both cases, let's do this so that we can see where we are. I'm going to put an invisible dashed line here because the end behavior again is after the dashed line. So the end behavior is bigger than the largest root and smaller than the smallest root. So this is the end behavior. Okay, so this is where I don't need to pick any points. So in both cases, the polynomial is going to go down. So after the negative square root of 2 root, the polynomial is going to go this way, and same goes for the positive. Okay. Now, in the middle, notice I need to pick a point between the negative square root of 2 root and the 0 and the positive. So I'm going to pick a point in between. Okay, so I'm going to pick a point. Let's say that this is 1. I'm sorry, -1 and 1. And I need to see what the function looks like in those places. Okay, so I'm going to do it up here. So I need to find f of 1, and I need to find f of -1. Okay, and obviously I'm going to use this format. So -1, 1 to the fourth, plus 4, 1 squared. So 1 to the fourth is obviously 1 times -2, -2, plus 1 squared is 1 times 4, 4, so 2. So let's say that 2 is, I don't know, let's say 2 is right here. Okay, say that this is 2. I am going to delete this information. We don't need it anymore. And same thing for -1. So -2 times -1 to the fourth plus 4, -1 squared. But that's the same thing, right? Because -1 to the fourth is 1, -1 squared. So that's the same thing. So it's the same number 2 right here. So I have these 2 points. And now, I think they should have been done in blue. Okay, so now I have all of the points that I need. Okay. And I don't know if you know which points I'm talking about. So change the color. This is one root. The function goes through these points that I have right here. Okay, I'm going to delete Don't need this anymore. And the end behavior. So the function has to go through these points that I have, and it has to follow the end behavior. There's missing one right here. Here's, oops. Here's the y-intercept, which is also one of the roots. So you have to trace a line through all of these 1, 2, 3, 4, 5 points following the end behavior. So it's going to be this way. So let's see if we can do this because it's, again, kind of hard. Okay. So I'm going to even, and the multiplicity of the radical 2 is odd, so it's going to cross, but the multiplicity of 0 is even, so it's going to bounce. And sure enough, look, let's do the 0 first. Here's the bounce, and I have to go through the square root multiplicity, right? Same thing here. All right, so this is what the graph looks like. Now, again, obviously, if we're doing this on paper, this is how we would do it. All right, so let's see, this is, all right, and then we would put the values here. And this is 2, and this is -1. This is positive. Okay, so this is what the sketch of the graph looks like. To do a better job than that, we would need calculus, but this is all that we need. We need to, in this particular case, factor the polynomial. We did find the y-intercept, find the root and their multiplicities, find the end behavior, and it's very important in this case, we need to pick a point, in this case 2 points, pick a point between the roots, right? So we need that to know where the function is. Otherwise, you could have graphed the function this way right here, and it would be incorrect. Okay, so when graphing these polynomials, you are going to follow these 5 steps as I have specified over here. Okay? If the polynomial is not fully factored, you factor it. Find the y-intercept. Find the end behavior using the leading coefficient test. Find the roots and their multiplicities. Plot one point between each root, and then trace a line, a smooth and continuous line through these points. And that would be the procedure that we're going to use to graph these polynomial functions.